Hi, welcome everyone. Myself Deepak and welcome to my YouTube channel. So today we are starting over new topic, that is the naive-Bayes classification. So what is a naive-Bayes classification? We can study this whole concept in detail, as it is the most important algo in the machine learning. That's why you must have to focus on this particular algo in detail as well, and you must have to understand the basic as well as the higher level concept of the naive-Bayes classification in this complete video. Moving further, so what is naive-Bayes classification? Before going through that, I am always taking the gates labels of the DA. That what is the supervised machine learning we have already covered. Regression classification problem we have covered. Simple linear regression, multiple linear regression, ridge regression, logistic regression, k nearest neighbor we have covered till now. In this today's lecture, we will proceed with the naive-Bayes classifier, that is your lecture number 7. So for the above topics, you can go and visit to my YouTube channel and study these topics from that lectures one by one. Okay, proceeding further. So I hope lecture 1 is of the supervised learning, 2 is for the linear regression, 4, 5 and 6 total 6 lectures we have already uploaded in over YouTube, so you can just visit there and definitely it will be beneficial for you. Now we are on the lecture number 7, that is the naive-Bayes classifier or the classification. So there are three terms basically come into the picture, that what is a naive, what is a Bayes, and what is the classification. So these three terms we can study in detail one by one to understand the complete algorithm. So over first content part is the what is the classification and when we use the classification algo. Although in detail what is the classification, what is the regression, we have already discussed in our previous lecture, that is lecture number 1 and the lecture number 2. So you can go and visit to that lecture to understand in the depth of this complete classification and the regression. But in this today, since I think that some of the viewers are the new, so we can again explain this in a short manner, that what is the classification. Then we will proceed with what is a Bayes theorem, as naive-Bayes classification or the naive-Bayes classifier is completely dependent on the Bayes theorem, which you have already studied in your class 11th and the 12th. So it is even also in your discrete mathematics in the semester 1, you have finished this complete Bayes theorem in detail already. But still we can take some glimpse of what is a Bayes theorem, so that it will be a bit easier for you to understand what is a naive-Bayes classification algorithm. So as it is always be said that naive-Bayes algo is the most important algo in the machine learning and the supervised machine learning. So you must have to be understand in depth, as you always found questions in the interview, in the gate examination, always found the questions in multiple, we can say that competition examination. Multiple time you will encounter this naive-Bayes algorithm in your different examination as well. So you must have to understand in depth what is the basic concept to the advanced concept of the naive-Bayes algo. In this complete video, I can take two major problems to solve how we can solve this naive-Bayes classification types. So it is very basic algo. You can easily understand this particular type of algo. So when we use the naive-Bayes and what is the naive-Bayes types, at last we can discuss that. Coming forward, so what is the classification? First, you need to be understand that what is classification and how classification proceed. So classification, as we already discussed, that it is nothing but the supervised machine learning technique used to categorize the data into predefined classes. So classification is nothing but it is we can just simply say that supervised machine learning technique which mainly classifies the different classes. So predefined classes it can classify. For example, if you have the two types of fruit, one is a orange, second one is a apple. So you just classify them. That is, one is the one class is the apple class, second is the we can say that orange class. So these two classification will be done by the classification technique. This is known as a classification algo. So it predict the categorical labels. Example, spam or not spam. For example, whether your mail comes into the spam mail or the non-spam mail, we can consider this. Positive or the negative sentiment. Whenever you found that multiple times sentiment analysis will be done. So whether a particular sentiment is a positive or a negative, we can say that on the Instagram, on the YouTube, there are different sentiments or the comments are posted. So whether that particular sentiment is positive or the negative, how we can predict? Since there is a classification of two different classes, so we can proceed with the classification that, or we can put this particular problem in the classification problem. So just simply when the output is variable, is categorical or a discrete, yes or no, true and false, disease or non-disease, then we can use this classification problem. Examples: email spam detection, medical diagnosis, fault detection. All these are the simple examples of the classification problems. Moving forward, what is a Bayes theorem? I can just provide you some recap because it is the most important concept on the naive Bayes classification. So, since the name itself come into the Bayes, naive Bayes, so it is again a very important. So you must have to understand the basics of Bayes theorem, that what is a Bayes theorem and how the probability is calculated by using the Bayes theorem. Okay. So, as you have already studied the Bayes theorem in your class 11th and 12th, you found this simple formula multiple times in your chapter probability of 11 12 as well as in the discrete mathematics. You find multiple time this formula, that is p of a by b is nothing but is equal to the p of b by a multiply of p of a divided by probability of any b. Okay, so it is nothing but we can say that if you find the p a by b is nothing but the posterior probability, that is probability of hypothesis A given evidence of B. You always keep in the mind that what this P A by B signifies. ये क्या सिग्निफाई करना चाह रहा है? ये बहुत ही सिंपल सी चीज सिग्निफाई आपको करना चाह रहा है कि सर बी अगर ऑलरेडी हो चुका है तो ए होने की क्या प्रोबेबिलिटी है. क्लियर? The same thing you have already studied in your class in the previous classes also, that you need to be think that B is already done, and if B is done, then what is the probability of A? If I'm just explaining you by the help of a diagram, so you found that if this is your probability of A and if this is the probability of B, then P B by A is this. Okay, if A is already done, then what is the probability of B? Okay, here you found that A is already done, and on this A, B is overlapping. Okay, if B is overlapping on that, what is the probability of B when A is already done? So this is known as a P B by A. So P B by A is nothing but we can say that likelihood or the probability of evidence B given when hypothesis of A. Okay, so I think these two terminologies are easily clear, that what is P A by B or what is P B by A. Similarly, if for the above also, you can just think that if you have B already done, so this time I am just doing this at, this is the B segment, this is the probability of B. I hope you all are familiar with the Venn diagrams. So this is the probability of B. If B is already done, then what is the probability of A? Then what is the probability of A? So this overlapping the B is already done, then what is the probability of A? This is denoted by this Venn diagram, that is P A by B. Okay, so these two I think terminologies is clear to everyone, that what is P A by B and what is a P B by A. But along with these terminologies, you must have to know that what's their exact meaning and what is their technical terms they are using. So you found that P A by B, the technical term is posterior probability. Always keep in the mind, because in multiple examination they directly use this particular term. Okay, so at that time you must have to know that they are saying about P A by B. For P B by A, it is known as likelihood. Okay, so whenever you need to find the apply the Bayes theorem, you need to find P B by A, that is nothing but likelihood. Okay, so whenever I am using the term that we need to find out the likelihood, that means I am saying that P B by A, we need to find out P B by A. So this is nothing but probability of evidence of B given the hypothesis of A. I hope this is you all can easily understand what is P of A, nothing but the prior probability of hypothesis of A, that what is the probability of A. ये basically आपको बता रहा है probability of A क्या होएगा, probability of B, that is marginal probability of the evidence of B, that what is the probability of occurrence of B. So there are the four major terms in this particular thing. Number one is the probability of P B by A, probability of P A by B, probability of A and the probability of B. आई होप इन सब के नाम आपको आसानी से समझ में आ रहे होंगे. सर पी ए बाई बी पोस्टीरियर प्रोबेबिलिटी कहलाएगा, पी बी बाई ए लाइकलीहुड कहलाएगा, पी ऑफ ए जो होगा वो प्रियोर प्रोबेबिलिटी हो जाएगा, देन पी ऑफ बी इज द मार्जिनल प्रोबेबिलिटी कहला जाएगा. ये इनके टेक्निकल टर्म्स हैं जो हमें याद रखने हैं. So this slide I added to understand you three major probabilities which you have already studied again, that is single event probability. So whenever you are finding the probability of a single event, that is probability of A or probability of B or probability of X or probability of Y, then we can say that this is a single event probability. That is, you are finding probability of A only, your probability of B only, then it is known as a single event probability. Okay. If you are finding the combination of two probability, then it is known as a joint event probability. Okay, I hope in 12th or the 11th you definitely found this joint probability. So this is nothing but Px by B or Pa by B or Px comma Y, then we can say that it is a joint probability. And at last is the conditional probability. Okay, the terminology which is mainly used for finding this Pa by B, it's known as conditional probability. Okay, here you basically finding the conditional probability. This conditional probability, you are applying this and form a formula. This is known as a Bayes theorem. Okay, so conditional probability is Px by y. That means if this is already done, that is y is already done, and this is the x, then what is the probability of this Px by v? If y is already done, then what is the probability of x? This is known as a conditional probability. Okay, so only if you are finding only this Px by x by y, then we can say that you are finding the conditional probability. Okay, so moving further. Now comes to the most important part. I hope previously we have discussed about what is the classification. Okay, I hope you are able to understand that what is the classification. Next, I think you are able to understand what is a Bayes theorem. Bayes theorem is nothing but advanced version of the conditional probability, that you are just putting the conditional probability of Pa by B or Pb by A and multiplying with P by A divided by P of B. Okay, this is the Bayes theorem. And after that, since in the Bayes theorem conditional probability formula is used, that's why I have added this slide also to understand, to give you a glimpse that what is this Px by y or Pa by B. Okay, so moving forward, so two concepts till now you have cleared. Till now we have covered two major topics. One is the classification and second one is the Bayes theorem. Okay, now the third term comes to in the mind, that is naive Bayes. Okay, so naive Bayes is nothing but is a simple, we can say that, supervised machine learning algorithm based on the Bayes theorem. Okay, I hope till now the Bayes theorem concept is clear. So naive Bayes theorem is nothing but it is a simple supervised machine learning algo based on the Bayes theorem. It is mainly used for classification tasks. Whenever you are provided some classification tasks, then it is used. The called naive, why the naive is used? Because it assumes that all the features are independent of each other given the class label. Okay, so why naive is used? Naive basically means the strong also. So it provides you a strong assumptions that all features are independent. Keep that in the mind, that all features are independent of each other given the class labels. Works well with high dimensional data. Why naive classification algo comes into the picture? When you have a high dimensional data, then we can say that we can go with the naive classification algo. Sometimes most of the people will ask that you have the multiple algos for classification problem, then why we will proceed with the naive Bayes? So the basic answer for this is that it basically handles the high dimensional data. That's why we will proceed. If your data is high dimensional, then we can proceed with the naive classification. Example, text classification, spam filterings and all. Okay, so this is I'm just providing you the example that you have this glimpse of things, and you need to be some different figures are there, and you need to be classify these figures. Okay, so how, since it is a complex problem, that your model need to classify circle, the triangle, and the this green boxes, that is your squares. So if you provide this particular data to your model, and model need to be classify the different things into the different classes, then how it will classify? What this model do, it, there is a algo you are using, which is your naive Bayes classifier. Naive Bayes classifier, you are using a classifier here. Just you can understand for the understanding point of view, that this is a chip and you implement this chip on this particular model. In this chip there is a formula with the Bayes theorem. Okay, and on this particular Bayes theorem they can classify the different classes in different banners. Okay, so this basically chip, you can just think that it is a chip of classifier. So this classifier chip we can implement on this particular model, and on this model it will provide the desired output by classifying the different inputs, that these are the combination of different inputs and you need to be classify them. So you implement this chip on this particular model, and this model can classify these things differently, that it is the squares will make a different class, it will make a class for circles, it will make the class for triangles. Okay, so through this a naive Bayes classifier works. I hope a simple example will be easy to understand the complete naive Bayes classification. Now, most important, that how naive Bayes works in the machine learning. So there are the two major phases. One is a training phase, second one is a prediction phase. So in the training phase, you need to calculate the prior probability of each class from the training data. That is, you need to find out the P of A, P of B, P of C, how much different classes are given. Then you need to calculate the likelihood probability. I hope now you are able to relate that what is the likelihood probability and what is the prior probability. I can go back again on the previous slide so that you can easily recall that these are the prior probability, these are the likelihood probability. Okay, PB by A is nothing but the likelihood probability. So first step, you need to calculate the prior probability, and on the second step, you need to calculate the likelihood probability for each features given in this particular class. So this is your training phase. Second is your prediction phase. So for the new instance, you just in this initial training phase, you train your model. ओके आपने ट्रेनिंग फेज में आपके मॉडल को ट्रेन कर दिया है. ट्रेन कैसे किया सर? पहले प्रियोर प्रोबेबिलिटी निकाली हर एक चीज की, और उसके बाद लाइक्लीहुड प्रोबेबिलिटी हमने हर एक जितनी भी क्लासेस है उनकी लाइक्लीहुड प्रोबेबिलिटी वहां फाइंड कर दी. जैसे ही हमने लाइक्लीहुड प्रोबेबिलिटी फाइंड आउट कर दी, ये हमने प्रियोर प्रोबेबिलिटी फाइंड आउट कर दी मॉडल की, तो मॉडल का ट्रेनिंग फेज कंप्लीट हो गया. आफ्टर ट्रेनिंग फेज प्रेडिक्शन फेज आएगा, तो हम एक नया इंस्टांस दे रहे हैं, कोई भी हम नया एक एक्स क्लास इसको दी, वी डोंट नो व्हाट इज दैट पर्टिकुलर क्लास, एंड यू नीड टू कंप्यूट द posterior probability. Okay, in this training phase you need to be go with the likelihood probability, but in the prediction phase you need to find out the probability of posterior probability. That is, in the initial you are finding P B by A, and in the prediction phase you find out the P A by B. Okay, for each classes. Then choose the class which is the highest probability, और जिस क्लास की सबसे ज्यादा probability आ रही होगी हमें वो क्लास चूज कर लेनी है, वही आपका एग्जैक्ट आंसर होएगा. क्लियर? आई होप ये थिंग क्लियर आपको समझ में आ चुका होगा. हम आगे बढ़ते हैं. देन व्हाट आर द टाइप्स ऑफ naive Bayes इन द मशीन लर्निंग? देयर आर द डिफरेंट टाइप्स. Gaussian naive Bayes that use when features are continuous and assumed to be follow as a normal distribution. Then multinomial naive Bayeses are there, that is used to discrete counts, example word counts in the text. Bernoulli's naive Bayes will be also be there, that is used for the binary features, example word word presence or the absence. So for these basically are used for the interview point of view, that sometimes in the interview they are asked that what are the different types of the naive classifiers or the naive Bayes. So you can just simply told them that Gaussian will be there, then you have the multinomial, then Bernoulli's naive Bayes are present in your different types of the naive Bayes. Okay, moving further. Now, the most important, now here you need to be solve a numerical. So this numerical is again an important numerical based on the different data sets, that is hours, notes and the slip. You need to find out a result of your particular student, that based on, for example, if someone study for the high hours, prepare a good notes and get enough sleep, then definitely the result is the pass. Same, we have the total 6 datas here, that is 1, 2, 3, 4, 5 and the 6. So based on these 6 data, you need to be define or find out the basic probability of a person, whether it is fail or the pass. So let's use the data to provide the predict whether a student will pass or fail. You need to be find out whether a student pass or fail on the study hours, note quality and the sleep. Okay, so study hours के ऊपर, notes quality के ऊपर और sleep के ऊपर हमें ये predict करना है कोई एक पर्टिकुलर बच्चा XYZ वो पास होएगा या फेल होएगा. तो पहले हमें मॉडल को ट्रेन करना पड़ेगा इस पूरे डेटा सेट के ऊपर जो ऑलरेडी गिवन है, और फिर उसके बेसिस पे हमें उसका एक रैंडम कोई हमारे पास आ रहा है स्टूडेंट का डेटा कि उसका पास है या फेल है बच्चा, वो हमें प्रिडिक्ट करना है, तो वो हम प्रिडिक्ट करके बता सकते हैं. सो आई थिंक हाई फॉर हाई वी हैव 3 here, low we have 3. Similarly, I think here pass are 3, fails are 3 combination. So moving further, I have since we need to make the video in the short manner, so some calculations I have already done and the mention to you. So first you need to calculate the prior probability. I hope this can a very easy task, and even the probability, these simple probabilities you have already calculated multiple times in your from your class, even not from the 11th and 12th, from your 10th or the 9th also. So if we say you need to find out the probability of pass, probability of fail, so you just simply say that there are the 3 pass students and 3 fail students. So there are the 3 pass students in the results, 3 pass students are there and the 3 fail students are there, and the total are 6. So what is the formula for probability? If I am saying that probability of pass, then we can just say that total number of pass students, that are the 3, divide by the total numbers of the pass plus fail. So total pass plus fail is nothing but 3 divided by 3 plus 3, which comes out to be 3 by 6, that is 1 by 2, and 1 by 2 is represented as 0.5. Similarly, sir, if you are finding the probability of fail, so for the fail, we just simply write that amount of number of students fails divided by pass plus fail, total comes in the bottom, or we can say that in the denominator. So fail students are 3 and total are 6, again 1 by 2, which is equal to the 0.5. Okay, so the probability of getting a student pass or a student getting the fail is similar, that is 0.5 or the 0.5. So here is the calculation, that is 0.5 and the 0.5 you are getting for a student will be pass or the fail. So this is the prior probability you have find. The first step you have already done right now. Moving further, so we now second step is you need to be find out the likelihoods. Okay, that is you need to find out the conditional probability. Okay, so we calculate the likelihood of each features. So what are the different features in your particular problem? That is, what are the study hours, notes quality, sleep quality for both the pass and the fail. Okay, so you have the basically 3 features here for pass as well as the fail, that is study hours, then notes quality, then sleep quality. So same you need to be find out the probability for, and which probability? Conditional probability for study hours, notes quality and sleep quality. All this work you need to be done in whenever you are solving a problem of naive Bayes, since it's a bit calculative problem. So the questions which will be asked in the gate definitely contains the more marks. Okay, so P, but the question once you see the complete video, you found that questions a bit easier, आपको बहुत आसानी से solve हो जाएंगे जिस हिसाब से मैंने समझाया, आपको बस उस according करते हुए जाना है पूरे numerical को. इसमें समझाते वक्त टाइम ज्यादा लगता है, अदरवाइज आप नॉर्मली खुद सॉल्व करेंगे इस पर्टिकुलर प्रॉब्लम को तो बहुत जल्दी जल्दी कर देंगे, क्योंकि कई जगह आपको कैलकुलेशन इन्वॉल्व नहीं करनी. फॉर एग्जांपल अभी जस्ट हमने देखा कि पास कैसे हो रहा है बच्चा, फेल कैसे हो रहा है, उनकी प्रोबेबिलिटी निकालनी है, तो आप क्विक व्यू में देख लोगे. मल्टीपल प्रैक्टिस अगर आप करोगे तो दिख रहा है आपको सिंपल 3 डिवाइड बाय 6 दैट इज 1 बाय 2. आपको कैलकुलेशन लिखना नहीं है, उसको डायरेक्टली लिख दिया आपने कहीं रफ पेपर जो आपको मिलता है गेट के अंदर. उसी तरीके से सारी प्रोबेबिलिटीज आपको कैलकुलेट करने की जरूरत नहीं, डेटा सेट आपके सामने दिख रहा है, फटाफट कैलकुलेट कर देंगे. यहाँ पे हमें सिंस समझाने के पॉइंट ऑफ व्यू से रखना होता है, तो दैट्स वाई ये सारी कैलकुलेशन इतनी बड़ी बड़ी आपको दिखानी पड़ती है. तो P इज द स्टडी आवर्स. इफ आई एम जस्ट फाइंडिंग द प्रोबेबिलिटी व्हेन स्टडी आवर्स आर हाई, then you need to be find out the probability for pass. For study hours are high, we find the probability that is 2 by 3. How this will comes? So you find that study hours अगर high है, passing a student, if you have the high study hours, then what is the probability? So you just simply see this, that for the high, you found that here study hours is 2 by 3. So just simply go and find out that. So study hours high, and student is passed, that 2 out of 3 will be there, that 2 out of 3 passed students have the high study hours there. So we just simply write 2 by 3, that is 0.6. Similarly, study hours low and a student is already passed, so one is there, only one student will be there with the low study hours, but it is passed. So in that case we just simply write that simply 1 by 3, that is 0.33. If the we can just simply notes quality good, if the student is passed by the notes good notes quality, then you find out 2 out of 3. Similarly, pass, the actual probability is 0.6. 2 by 3 you just simply calculate in by the calculator, then it comes out to be 0.6. If a student is passed but the notes quality is poor, you found the probability is 0.3. Just simply you just find the pass and yes, then just 3 out of 3 will be there, that is 1 by 1 is the exact probability. Then you just 3 fails out of 6. So how you can find out there? So for the fail, if high, so 1 out of 3 will be there. Here you found that one condition where a student is fail, still having the high study hours. So only one case will be there. So 1 out of 3 will be comes there. So you find out 1 out of 3, that is 0.33 will be there. And fail with the low study hours, so there are the two cases. So 2 by 3 will be there, that is 0.6. Then it is again fails with the good notes, that is 1 by 3. Then similarly fails when poor notes, so again 2 by 3. Fails with the good sleep quality. Here you can easily understand that we are finding for each and every feature. So study hours will be there, notes quality will be there, sleep hours will be there. Okay, so for the study hours we are finding for the fail. Similarly we have find out for the pass. So here multiple probabilities you need to be calculate. Always keep in mind. So you need to be do multiple questions on that, so that at the time of examination you can easily understand and you do not skip any probability. ओके सो इट मतलब आप एग्जाम टाइम में कोई भी स्किप ना करें. जैसे वहां पे आपको केसेस बनाने पड़ेंगे, जैसे हमने यहाँ पे केस बनाया कि सर पहले पास के साथ देखेंगे स्टडी आवर्स ज्यादा हैं, नोट्स की क्वालिटी और स्लीप क्वालिटी. उसी तरीके से फेल के साथ ही केसेस हमने बनाए और उन केसेस को हम डिस्कस कर रहे हैं. तो पहले हमने पास वाले केसेस डिस्कस कर लिए, फिर हम फेल वाले केसेस डिस्कस कर रहे हैं. ठीक है, तो नेक्स्ट स्लाइड में हमने फेल वाले सारे केसेस डिस्कस कर ली कि सर फेल में कौन कौन से केसेस बन के आ सकते हैं. तो फेल में यहाँ के लिए सर हम बोल सकते हैं स्टडी आवर लो हो सकता है या हाई हो सकता है. जैसे फॉर एग्जांपल यहाँ पे मैं पीछे जाऊं तो स्टडी आवर्स लो और हाई, क्वालिटी लो हाई, ऐसे हम हर एक के दो केसेस और बनेंगे. वो सारे केसेस आपको बनाने ही पड़ेंगे एट द टाइम ऑफ एग्जामिनेशन. सो टोटल 12 cases will be there, 2, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have discussed the 6 cases, 2, 2 and 2, 6 cases will be there. Here we discuss the 6 cases. Similarly sleep quality पे डिपेंडेंसी हम देख रहे हैं. अगर बच्चा फेल ही है, हमें पता है ऑलरेडी बच्चा फेल है, तो यस स्लीप क्वालिटी में हम देखें येस और नो की जो कहानी थी, तो वेयर वी हैव फाउंड द 1 out of 3. दिस यू कैन जस्ट ओपन द डेटा सेट देयर एंड पैरेलली सॉल्व दिस, सो यू विल गेट. ओके, तो ये सारी प्रोबेबिलिटीज हमें फाइंड आउट करनी पड़ेगी. मूविंग फर्दर, नाउ यू नीड टू अप्लाई द बेस थ्योरम टू प्रिडिक्शन. So here a case is given, a model case is given that it is study hours is high, notes quality is good and the sleep quality is yes. Then what is the particular thing, the whether the student is pass or not, you need to be find out. So for that you need to be apply a particular Bayes theorem formula. Okay, so we can apply the Bayes theorem formula here. So now we need to be find out a probability of whether a student is pass when the study hours is high, when notes quality is good and sleep quality is good. Okay, you need to be find out the probability there. Okay, the sleep quality is good, that is yes, a good sleep quality. So what is the formula by using this particular Bayes theorem? You find out, since you need to be find the probability of pass there, so that will be multiplied by which, PB by A. So PB by A is nothing but probability of, we just simply say that, simply write P of, just say P by A, you need to be find out the SH is equal to the high for the pass, probability of notes quality is good for the pass, and simply probability of sleep quality is yes for the pass. Okay, so you just simply divide by is not need to be find out, just simply go with directly, since all these things are directly proportional and both of divide by denominator will be always be same in both the cases, in the pass as well as for the fail case. So divide by denominator will increase your calculation, that's why we just simply ignore that, and since it is an independent part, that's why you can also ignore the denominator there. Okay, so moving further, just putting all the probabilities formulas and just simply the calculation of that particular formula. So you will find the probability of pass part, then this part. So here you will find the, since our probability of getting the pass is 0.5, and then we have the probability of high score when a student is passed. At that particular of time, you will just simply go with 2 by 3. Then you just go with 2 by 3 of high quality. Then just simply with the good sleep, then you will get the probability of 1 there. That's why after calculating all these things, you will found that the result comes out to be this. Simply we can just simply say that 0.222 you will get the result. Similarly, for the pass, you can find out a probability for getting the student for fail. Okay, just like that, you need to be find out the Bayes theorem for the student getting the fail. So for this, we just simply write, okay, pass. For the pass, we have already find. For the sleep quality or the notes, we can just simply write. For the high notes quality good, okay, it's high notes quality is good, and sleep quality we just simply write yes. In that case, you will get the Bayes, by the Bayes theorem, we will get the probability of 0.222. 0.222. Now you need to be find out, this is for the probability for the pass, and for the fail, you need to be find out the probability for fail. Similarly, जो आपने ऊपर काम किया है वही काम आपको यहाँ पे अगेन करना है. Where the sleep quality is high, notes quality is good, and this is, I think, not the sleep quality. The first is your study hours. Okay, so this is the sleep quality is yes. Now you need to be find out the probability for getting the fail. So for this, first you need to be just recall that formula. P A by B is there, then it's simply just writing you here. If P by A will be there, so you just write here P by A multiply by P of B by A. P of B by A there, divide by P of B. So since P of B is similar in both the cases, so you can ignore that as well. Or since it is an independent, that's why we also ignore that. You just work on the initial part, because you need to compare at last the probability. Which probability comes greater, that probability is your major answer. Okay, हम देखेंगे कि सर कौन सी probability ज़्यादा important है. जिसकी probability ज़्यादा आएगी उस केस को हम ले लेंगे. मान लीजिए अगर आप P by A कंसीडर कर भी लेते हैं, यहाँ पे P by B कंसीडर भी कर लेते, तो भी इसमें भी तो P by B रहता, तो सेम नंबर से डिवाइड होने पे उस पर अफेक्ट नहीं पड़ेगा. सो व्हाई वी आर गोइंग इन दैट मच ऑफ कैलकुलेशन, इसलिए हम उसको इग्नोर कर रहे हैं. हमें तो आसान करना है ना चीजें, हमें जल्द से जल्द हमारी कैलकुलेशन निकालनी है, वहां हमें बहुत सारी कैलकुलेशन में नहीं फंसना है. तो हम क्या कर रहे हैं, कैलकुलेशन सिंपली निकाल रहे हैं यहाँ पे. तो हम P by B को हम यहाँ कंसीडर नहीं करते हैं. सो प्रोबेबिलिटी ऑफ, हाँ, स्कूल एग्जामिनेशन या फिर just university examination, you can just go with that. You can easily find out there. Okay, so here we can just simply say that probability of fail you can find multiply by, okay, P of A multiply by P of B by A. Now you need to, P of B is all these features, so you just multiply one by one that features. That is probability of, you just go with probability of high score when the student is fail. Similarly, multiply by notes quality good, assuming that student is fail. Similarly, sleep quality is good, assuming student is fail. Okay, so all this you need to be calculate now. Okay, again the similar way, just you have already find out in the previously past, just in the okay. So probability of fail is again 0.5 you have, and for this this previous fail case, you can just take it from the fail, that is 1 by 3, 1 by 3 and 1 by 3 we have. So just multiply with this 1 by 3, 1 by 3 and 1 by 3. So you will get a particular answer. By the calculation, you can just simply get this, that in the examination you just simply calculate by the calculator and you will find the exact. So now you will getting the two probabilities. Probability for a student getting the fail and for the pass by the Bayes theorem. So here you found that the probability of getting the pass is greater than the probability of getting the fail. Okay, the probability of getting the pass for the desired features is greater than, we can say that it is greater than, okay, than the probability of getting the fail for the desired result. That's why the prediction comes out to be, that's why the prediction comes out to be pass. Okay, I hope the basic concept of the naive Bayes classifier is clear to all of you. We have just taken a simple example in which we just find out whether a student is pass or not. So here is a particular data set. On that particular data set, you need to be find out a student is pass. So first you find the prior probabilities. After you find the probabilities based whether the student is pass or not for each and every, applying the conditional probability. After that, whether the student pass and the fail, you find the conditional probability. Then at last you will apply the Bayes theorem. Okay, and the basis of the Bayes theorem, you will getting the two probabilities for the pass and the for the fail and the for the pass, and you find the for the probability for the pass is greater than the probability of the fail. That's why your prediction of for that particular student is, it is pass. Okay, so I hope this we will getting the exact probability, and we find that since pass is greater than the fail, the prediction is pass for this example. So this is a basic example for the if any 1 or 2 marks will be there. Mainly the naive Bayes classification problems comes out in the 2 marks problem. So that's why I hope this problem you can easily understand. Okay, so okay. सो हेयर वन मोर प्रॉब्लम, सम एडवांस लेवल प्रॉब्लम, इससे ऊपर गेट कभी नहीं जा पाएगा। जो मैंने एडवांस लेवल एक और प्रॉब्लम आपकी डाली है, ये दो प्रॉब्लम्स अगर आप करके चले गए तो डेफिनेटली यू विल इजीली crack the any question which is asked related to the naive Bayes theorem. So इससे ऊपर कोई भी आने वाले 5 से 6 साल तक भी नहीं जा पाएंगे। ठीक है, तो ये प्रॉब्लम बहुत सिलेक्टिवली डाली है, इसमें
क्या बात है सर, क्या बात है सर, क्या बात, ये बात है।
स्पेशल केस हमने देखा है जिसमें हमने लाप्लास स्मूथनिंग देखी है। अलॉन्ग विद द नेव बायस थ्योरम लाप्लास स्मूथनिंग का एक कंसेप्ट आता है, वो हमने इसके अंदर मैंने ऐड कर दिया है, सो दैट अगर बहुत ज्यादा टफ पेपर भी बन गया तो भी इससे ऊपर नहीं जाएगा। तो एक ही क्वेश्चन है, मैंने फटाफट आपको इसको गो थ्रू करवा लेता हूँ बिकॉज हमें थोड़ा सा वीडियो लेंथ शॉर्ट बनानी है। एक क्रैश कोर्स टाइप आपके पास जाए तो दैट्स वाई इतना ज्यादा इन डिटेल अपन इसको एक्सप्लेन नहीं करते हैं। यू कैन पॉज the video whenever you required to understand that particular concept, otherwise go with the calculations which I have already done here, and you can easily understood that particular problem. Okay, so we want to predict a student will pass or the fail. Same problem मैंने उठाया लेकिन यहाँ पे कुछ चीजें चेंज हो चुकी है। So same data set a bit changes may be there, but otherwise almost approximately same data set we have used. You can take this screenshot of that. Now you want to predict for a new student, so same simply just hours are high, notes is good, and sleep it will there will be no sleep. So features, you have the three major features, that is hours will be there, which is high or the low, notes whether it is good or the poor, or the sleep quality whether it is yes or no. Then target variable whether the student is pass or the fail. Quickly we will proceed. So you need to be first calculate the prior probability, then you need to calculate the features probability, that is likelihood, then after that you need to apply the Bayes theorem. ये तीन स्टेप हमने पहले वाले क्वेश्चन में भी करा है, सेम स्टेप आपको इस क्वेश्चन में भी करना है. So there are the total records are 6 as you see in the data set, that we have the total records are 6, 1 2 3 4 5 6. So total records are 6 there. Pass are 3 and the fail are 3. So pass probability, that is prior probability, you can calculate first, then the fail probability you have calculate next. Then after that prior probability for the pass students we will calculate, for the fail the same we have already done, but here you find the if sleep is no, then the probability comes out to be 0, and for the speed fail you will found the probability is equal to the, for the sleep is equal to the 0, probability will be the 1, and some probability is also 0 here, for the notes is equal to good and the fail is already done, then you will found the probability of getting a student will be the fail. In that case even having the good notes quality is comes out to be 0. Now for the past students the same thing you will calculate. So here you will find this proportional sign will be there, even you can use the equal to sign if you are just simply dividing by this particular using the Bayes theorem. Since we are eliminating the denominator, that's why we are just adding the use this proportionality sign. So here you found the probability comes out to be 0. Okay, सिमिलरली फॉर द फेल द प्रोबेबिलिटी कम्स आउट टू बी जीरो। सो यहाँ पे आपके पास जब प्रोबेबिलिटी जीरो जीरो दोनों में आ जाती है, इन दैट केस नया कंसेप्ट इवॉल्व होता है जिससे हम लाप्लास स्मूथनिंग के थ्रू इसको सॉल्व करना पड़ेगा। ठीक है, इससे एडवांस मुझे नहीं लगता कि आपके नेव बेस में जा पाएगा, क्योंकि ऑलरेडी इतनी कैलकुलेशंस आप कर चुके हो। अब और आपको कैलकुलेशन एड ऑन करनी है लाप्लास स्मूथनिंग की। सो वो इससे ऊपर मुझे आई कांट अंडरस्टैंड कि इससे ऊपर कोई भी प्रॉब्लम जाएगी। So both zero due to unseen combinations. That's why to solve this particular problem, you need to go with the Laplace smoothing. So here is the complete problem, that how the Laplace smoothing come into the picture. That is, if any single conditional probability equals to zero, तो आपके गेट में अगर कोई भी एक conditional probability आपके पास zero आ जाए, तो whole product become zero हो जाएगा. That's why this means an unseen feature value in the training set is completely rule out. Okay, any कोई भी एक unseen feature होएगा वो completely rule out हो चुका है. That class often we can say that is often undesired. In this, a zero frequency problem comes when both classes scores are zero. You cannot decide between the classes. Moving further, this is the formula for the Laplace smoothing, that is f of v by v divided by for the class is nothing but the count for f is equal to y for the class plus n of class plus v of f. Where n is a class for the number of training example, and for that particular class we can simply say that v of f is the number of possible values for that particular feature. ये फॉर्मूला आपको एक रिमेंबर करना है, रटना पड़ेगा, ये इसका कोई आपके पास सॉल्यूशन नहीं है. लाप्लास स्मूथनिंग के लिए एड वन हमें कर लेते हैं, क्योंकि ताकि वो जीरो ना हो पाए, तो यहाँ पे हम एडिशनल वन एक ऐड करते हैं इन अ कैटेगोरियल पर्टिकुलर फीचर. दैट्स व्हाई इट इज नोन एज अ लाप्लास स्मूथनिंग. एक डिटेल वीडियो हम बना देंगे लाप्लास स्मूथनिंग के ऊपर. तो क्लास पास है, टोटल पास आपके पास हुआ है, तो विद द काउंट इज 2, गुड विल बी 2 एंड देयर विल बी नो इक्वल टू 3. सो काउंट्स आर हाई. these are the different features you have. For that particular you will get the probability 0.5. ये हमने पहले ही कैलकुलेशन कर रखी है, इसलिए इसको आपको ज्यादा जाना नहीं है, ये पहले से हमारे पास प्रोबेबिलिटीज 0.5 आ रही थी. देन आपको अब अप्लाई करनी है लाप्लास स्मूथनिंग. सो फीचर हाई और गुड के लिए आर फ्रॉम 3 valued categorial variables आपको देखेंगे, that is v equal to 3. Similarly no के लिए हम देख रहे हैं v की वैल्यू जो आ रही है वो 2 आ रही है. सो इस केस में हम अप्लाई कर देंगे लाप्लास स्मूथनिंग. तो दैट इज 2 + 1 डिवाइड बाय 3 + 3 which comes out to be 0.5. नाउ 2 + 1 डिवाइड बाय 3 + 3 0.5. हियर 1 कम्स, पहले 0 था आपके पास, तो अब +1 करने से 1/5 आ गया, यानी 0.2 हो गया है. सिमिलरली सर हर एक में हमने +1 कर दिया, तो हमारे पास प्रोबेबिलिटीज पहले से चेंज हो चुकी है. अब आपके पास 0 कहीं पे भी नहीं आ रहा है. क्लियर? सो जैसे ही 0 नहीं आएगा तो उनका प्रोडक्ट्स आपने निकाल दिया बाय यूजिंग द सिंपल पोस्टीरियर स्कोर्स. सो दीज आर 0.25, दैट इज 0.022. सो आफ्टर दैट एक्चुअल पोस्टीरियर प्रोबेबिलिटी आप निकालेंगे, सो दैट यू विल गेट द 0.595 एंड फॉर द फेल यू विल गेट 0.47. सो ये दो चीजें आपको निकालनी पड़ेगी. तो जैसे ही आपने पोस्टीरियर प्रोबेबिलिटी निकाली फेल के लिए और पास के लिए, you will find a difference in the values. So here you find the value difference is above is more as compared to the pass. So pass के लिए केस ज्यादा आ रहा है, probability ज्यादा आ रही है, इसलिए सर हम उस केस को बोल देंगे classify as a pass. That student is classified as the pass. ये थोड़ा सा मैंने जल्दी आपको एक्सप्लेन किया है. लाप्लास स्मूथनिंग के लिए एक अपन इन डिटेल वीडियो अलग से बना देंगे. इस तरीके के जो भी एडिशनल कंसेप्ट्स हैं जो आपके पर्टिकुलर कंसेप्ट को, एक पर्टिकुलर प्रॉब्लम को एनहांस कर दें, कोई एडवांस लेवल पे ले जा लें, वो सारी प्रॉब्लम्स को हम सॉल्यूशन आगे वाले टाइम में एक अलग से वीडियो बना देंगे. ये सारी स्मूथनिंग क्या होती है, गॉसियन कैसे आप यूज कर सकते हो, ये सब हम अलग से एक वीडियो में भी डिस्कस करेंगे. आई होप लेकिन फिर भी ये समझ में आ गया है. लाप्लास स्मूथनिंग में आपको क्या करना है, केवल +1 करके प्रोबेबिलिटीज फाइंड आउट कर देनी है, ताकि चीजें जीरो ना आ जाए. क्योंकि जीरो जैसी आ जाएगी अगर आपकी किसी भी प्रोबेबिलिटी का केस, तो हम उस केस में लाप्लास स्मूथनिंग लगा के काम शॉर्ट आउट कर देंगे. क्लियर? दैट्स इट फ्रॉम माय साइड. सो आई होप यू लाइक दिस वीडियो. थैंक यू सो मच. हैव अ नाइस डे. टेक केयर स्टूडेंट्स.